What is Euclid's division lemma? We'll find the answer to it by the time this video gets over. We'll understand what it is with a very simple example. Meera goes to a shop with rupees 42 to buy balls that cost rupees 10 each. We need to find two things in this question. The first one, what is the maximum number of balls that she will be able to buy for 42 rupees? And the second one, how much money will she be left with after buying these balls? It's a very simple division equation. Let's set it up. 42 is the sum of money that she goes with. Each ball costs 10 rupees. So she will be able to buy 4 balls. She's going to go back home with 2 rupees. This is a division that we have done probably since class 4. We'll understand what these 4 numbers mean. The 42, the amount of money that she went with, is called the dividend of this division. Usually, let's represent it with an alphabet N for it. The cost per ball, 10, is called the divisor of this division. Let's call it D. The entire Euclid's division lemma always is applied on these two numbers to result in these two. The 4 that we have got in this division is called the quotient of this division. What does the quotient signify? The quotient tells us the maximum number of divisors in this dividend. How many tens? What is the maximum number of tens that we can have in 42? We can have 4 tens in this 42. The quotient is always an integer. The last number 2 is called the remainder of this division. This is what she goes back home with. Right? Let's quickly recap all these 4 terms in a printed form. This is a division equation. 42 by 10 leaves us with 4 as the quotient and 2 as the remainder. We'll quickly define what these terms are. 42 is the dividend. Let's call it as N. 10 is the divisor. Let's call it as D. 4 is the quotient of this division. Let's call it as Q. What does the quotient represent? The quotient tells us the maximum number of divisors contained in this number or in the dividend. In this example, 4 is the maximum number of tens that we have in 42. The last number, 2, is the remainder in this entire division. Let's assign a variable to it. We'll call it as R. We're going to make a statement. The statement is the remainder always takes a value that's less than the divisor. Obviously, the next question is, why is it so? Let's understand this. Meera can convert every rupees 10 that she has into 1 ball. She's going to convert all the money that she has till such time that she's left with no more money to convert or to buy the next ball. Every time she has 10, she will convert it into a ball. When is she going to stop? She is going to stop when she has a money, when she is left with a sum of money that is less than what is required to buy the next ball. What is required to buy the next ball? She requires 10 rupees to buy the next ball. If she has 9, she has 7, she has 6, she has any sum of money less than 10, then she will not be able to buy. And that is the amount of money that she is going to go back home with. So the remainder is what she goes home with. Remainder is what she is left with. That remainder will be less than 10 in this example. What is 10 in this example? 10 is nothing but the divisor in this division. So the remainder of any division will be a number that is going to be less than the divisor. How low can this value be? For a moment, let's forget that she went with 42 rupees. Let's say she went with the shop to shop with 40 rupees. Each ball costs 10 rupees. How many balls will she be able to buy? She'll be able to buy 4 balls. What is she going to go home with? With nothing other than these 4 balls. So the remainder can be as low as 0 and it should be a number that is less than the divisor. So how high can it be? Less than the divisor, it can be as high as D minus 1. So reminders take value from 0. Reminders take values from 0 all the way up to D minus 1. Quickly look at this logic once more and this equation in a printed form. Why is the remainder less than the divisor? Meera will convert every rupees 10 with her into a ball. When is she going to stop? She will stop when she does not have enough money to buy the next ball. Which means she's going to stop when she's left with a sum of money that is less than 10 rupees. That's when she's going to stop. So she will be stopping when she is left with, after buying the maximum number of balls, a sum of money that is less than what is required to buy the next ball. That is a sum of money that will be always less than 10. 10 is the divisor in this case. So a remainder will always be less than 10 or the remainder will be less than the divisor. How high can it be? It can be as high as d minus 1. How low can it be? That's where this question answers it. What if she had gone to the shop with 40 rupees? She would have bought 4 balls and she'd be left with nothing in hand. So remainder can be as low as 0 and it'll go to a value which is less than d. Now, let's basically write this entire division in an equation form. She went with 42, bought 4 balls each costing 10 rupees and she's left with 2 rupees. So the 42 that she went with can be written as 10 into 4 plus 2. This, in short, is your division lemma, Euclid's division lemma. So 42 is equal to 10 into 4 plus 2. What is this 42? 42 is the dividend of our division. What is 10? 10 is the divisor. What is 4? 4 is the quotient. What is 2? 2 is the remainder. So in general, Euclid's division lemma is n equals dq plus r, where r takes values from 0 to a number less than d. Euclid's division lemma statement basically is this. Given positive integers n and d, n is the dividend of the division and d is the divisor. The division lemma is applied on these two. There exists integers q and r satisfying n such that n is equal to dq plus r. R takes values from 0 all the way to a number less than d. It can go as high as d minus 1. One of the most important uses of this division lemma is actually computing HCF or GCD of a set of numbers. In the next video, let's find out how to go about finding out HCF of numbers using Euclid's division lemma.